Okay, so here we go. Number one, it's a question from the 2007 AP exam. So we have a setting right here with a sled. It's on a muddy hill. There is friction. With a constant speed of 2.4 meters per second. The slope of the hill, it's inclined at an angle of 15 degrees with the horizontal as shown in the figure above. Calculates the time that it takes the sled to go 21 meters down the slope. How do we find out the time in this case? Which equation would you use? Which is? What's the acceleration? Okay, yes. So you can use one of those kinematics equation, or if you can see the simplicity of this, this is a constant speed. I hope you caught that when you were reading the question. So that means we can simply use velocity is equal to displacement over time, the equation, and to solve for the time is equal to what? Distance over velocity, and this is all we need to do. 21 meters over 2.4 meters per second, and whatever that is, we will go ahead and use that as our 8.75. Okay, so we have 8.75 seconds as our answer. Okay, so do not get scared by the question. Sometimes the question is as easy as this. So if you can use the velocity as displacement over time, that's great. If not, you can still say that initial velocity is 2.4, final is the same, acceleration is 0. Okay, of course, we will also say the net force is 0 because it has a constant speed. All right, now, there's no dot on your paper. So on your paper, to the side of it or on a piece of paper, can you go ahead and draw a dot for part B? And on the dot, can you draw or label a free body diagram for the sled as it slides down the slope? So how many forces would there be, and what are the directions of the forces? All right, how many forces should there be over there? 3. Which 3? Normal, which is perpendicular to the surface. Gravity, which is straight down. And then what? Friction, which direction? Yeah, up the slope. Okay. And you can say friction, or you can also point out that it is the kinetic friction. Okay, so you have 3 forces, of course. Okay, when we do calculations, if we do any calculations, we would have to split the weight into 2 components. But for now, for the free body diagram, that would do it. Okay, and then part C and D, it says, please go ahead and calculate. Well, for part C is to calculate the frictional force, and part D is to calculate the coefficient of friction. So go ahead and see if you can calculate part C and part D yourself. So if you take a look at this diagram, the only reason why it could travel at a constant speed is because on the slope, right, we have FGX, and then we have the kinetic friction. They must equal to each other. And we know the mass of the sled, right, is 25 kilograms, and the angle is 15 degrees. So mass is 25 kilograms, and theta is 15 degrees. So the kinetic friction is basically the value of the FGX, which is mg sine theta, and that would be 25 kilograms times 9.8, or negative 9.8 times sine of 15 degrees. 63.4, okay. All right, 63.4 newtons, and we'll go ahead and put a negative in front of it because it's going in the opposite direction as the motion. Good, okay. And then for part D, it says, hey, could you go ahead and calculate the coefficient of friction? Friction? Oh, yeah, yeah, friction, that's friction, okay. Part D, calculate the coefficient of friction, which is, what equation do we use here? Fun, yes. So friction, it's equal to mu times normal force, okay. And we know, or we should know, two of them already. We just calculated the friction. We should be able to find normal force, which is now, but I want to show you something here. Okay, now of course you can go ahead, get the numerical value here, and then just substitute in and calculate the mu. But I want to do something different right here. We just calculated the f of k, right? That's mg sine theta. Yeah. So this is the second time I think we have seen this, right? So mg will get canceled out. So sine over cosine theta, it's equal to mu k. So that means mu k is simply tangent theta. And since theta is 15 degrees, so mu k is simply point to, let's go with 27. Okay. So that's now for part D. Of course, it's not wrong if you go ahead and do it with numbers. But I would say for physics, I want you to get a feeling that you always want to see a little bit ahead and then evaluate if there's anything to be canceled out to lessen your work. And that would always be a good thing to have. All right, now let's continue with the excitement. Now it says the sled reaches the bottom of the slope, and then it's going to hit a horizontal surface, right? Horizontal ground. Assume the same coefficient of friction, so same material, basically. So in terms of velocity and acceleration, describe the motion of the sled as it travels on the horizontal ground. Let me give you 1 minute and see if you can write a couple of sentences to describe how the sled moves. All right, so what's going to happen when it's going to what? Slow down. How come? Yeah, gravity is no longer there, so it's going to slow down due to friction. So in terms of velocity, it would start from 2.4. Eventually, it would reach 0. Okay. Now, of course, we are not asked to calculate anything quantitatively here. But now, if I ask you to extend this thought process, if you're gonna use kinematics equations to find out some information, such as how long would the sled stay on the horizontal ground, or how much, what's the distance that it would go forth, okay, on the horizontal ground, how would you do? How would you find out these info? So we have initial is 2.4, finally 0, and then what else? We can get this acceleration, but how? Yes, we will, but how? Very good. 240. Wait, hold on. 240. 245. Okay, yes. So you would still use the same equation, but in this case, the normal force has changed. So you need to update this normal force. You use the mu that you calculated earlier. Then you will get the friction, which is your net force. And then you can go ahead and say, all right, I got the friction force. Is equal to m times a. You get a. Okay, so A is a value that is within your reach, but it's not something that yeah, it's not something that you should yeah, it's something that was within your reach, but it's not given to you right away. So once you have these three pieces of information, you can get whatever you want. All right. So that's good. Part two. So can you go ahead and draw the graph? So it says at about there will be a time called TL, where that's the time that the sled leaves the slope. So can you go ahead and draw a graph, specifically a VT graph, to represent the motion of the sled? Very good. All right, so the first part should be pretty straightforward because it sets constant velocity on the slope, right? So I don't think anybody would miss this part. If you are asked to label, then you should be able to label this as 2.4 meters per second. Now, the major challenge is that after TL, how would the graph look like? What's the shape of the graph? Good. Why is that? It stops, but now my question would be this. Why not this? Why not this? Why this? Why is it a straight line? Why should it be a straight line? Yeah, this is a question that you need to be ready to answer. Because if you don't know, then that means you are only drawing a straight line by luck, not by your knowledge. Yes, because the friction is constant, there's only one force, and then we could calculate the value of A, and that would be a negative value, and that would be the slope of this graph, of this portion of the graph. So again, the slope equals to acceleration, and we could calculate acceleration. So what I want you to really see, and that I want to address one comment, and that is people would say, I want to do more conceptual problems. Cool. So does it mean that you don't have to worry about the numbers? Now, my perspective is that you should do more quantitative analysis so that you'll be more capable of doing these kind of conceptual questions. Because you need to know what is available, and then you can use the information that's available to you to calculate something. At least you can process the hypothetical scenario. If you don't do enough calculations, then you don't even know what equations to use and how to get around these questions. So I find the need of calculations will be very important. And we have done a lot of calculations last couple of weeks. So I think today it's a very good day to look at these more conceptual problems. And the next problem, it's going to be even more conceptual. Are you ready?